Okay, in this video we are going to shift our focus away from little background operations and all the intricate code back behind our game back into the world of music. Up to now we've dealt with a lot of systems that our game needs in order to play. We've got our screen system where of course now we're dealing with inputs and all this great stuff, but we haven't really been working with music insofar as the drum game is concerned, and that's what we're about to get with here. Now, in this video, what we're going to be coding up is the note class. Now, generally speaking, what does the note class do, Logan?
The note class is simply a storage container. Its job is to contain two key pieces of information.
And what are those pieces of information?
A tick, representing its placement in time, and a track, representing its placement on a different drum track.
Which in turn kind of controls what instrument it's going to play, whether it's a tom or a snare or a hi-hat or whatever.
Exactly, and since the game was divided up into index-based tracks, the note itself isn't going to care about drum definition. Rather, drum definition will be defined based on the sounds and names of the tracks.
Great. So this is just a container that stores a time and a track, which means this is going to be a very small amount of code. Once we start coding, this whole video will be pretty much done right about the same time that we get coding. So how does a note correlate into a song?
Well, a note is just a single unit that will be stored in a song.
Okay.
Or another way to look at it is a song will be composed of many notes.
Okay. So we have to get this note piece put together, and then later on we can start coding together our song system.
Exactly.
So let's go ahead and get started. Let's build our note class, and we'll put in the necessary code, and we'll just go on from there.
All right, so back over here to Visual Studio, let's get a new class put together. Over here in our Solution Explorer, we'll jump all the way back to Core, and we'll add a new class under Core. This class will be called Note. And let's see, let's begin by cleaning up our namespace.
Like we do.
And the note is going to have some very simple types inside of it. We won't even need to open up our XNA namespaces. So we'll jump directly into the note class itself.
Ooh, we're not using anything. Or, well, anything other than the default stuff that comes in.
Anything other than... Yeah.
Anything other than that.
But, all right, so we have our two key pieces of information, which are tick and track. Now, to be useful, both of these need to be accessible to everything outside of the note class. So we will make these fields public. Both are going to be integers. So we can begin with tick. And then we have public int track.
And that's our key right there, is the tick, which is the moment along our song, I suppose, that the note is going to exist. Is that how that works?
Yep. So
Okay.
that's almost like if you imagine a timeline composed of many ticks, you could say that each note drops into a slot on that timeline.
Gotcha.
And so it's this tick value that places it on that imaginary timeline.
Time over value.
And of course, track is simply which drum this note is associated with.
What else are we putting in here?
Well, to go along with these two, we also need to have some gameplay considerations for our notes. As notes are going by, we want to record whether or not they were hit. Because once you hit a note, generally you don't want the note to remain. It would be better to see it consumed, so to speak. So the moment you hit a note, have it disappear or explode or otherwise go away. That gives a good, solid visual indicator of the fact that you successfully hit a note.
So we're going to make a note aware of the fact that it's been hit?
That's right. This is, instead of destroying the note outright and pulling it out of the list, that would make our list a lot harder to manage because now the number of items in the list would be continuously changing.
Yeah.
It's a lot easier to just mark the note as being hit, and then later we can process hit notes appropriately. So in a rendering engine, we could simply skip drawing hit notes.
Okay.
And in an effect engine, we could cause effects based on the notes being hit.
Sure.
And then there will be one other piece of information, and that will be whether or not the note has been missed.
Well, let's go ahead and put in the field we have for hit first.
Okay. So let's drop this down. We'll make a public field of Boolean type, and we'll call this hit.
Which I guess is really all you need, because either it's been hit or it hasn't, yes or no.
Exactly. If it's been missed. Now, what's interesting is with hit and track, it seems like you would be able to calculate whether or not the note has been missed. If the note is not hit and it's sufficiently past the current tick within the song, that would constitute being missed.
Well, see, that's what I was thinking. If hit equals 0, then you didn't hit the note.
But the tricky thing is that means you have to always take the current song into consideration and do some offsets based on hit and tick and the current position within any song you may be playing. Inside of the song, when we're looking at notes and watching them pass by the imaginary hit marker, it would be more convenient if we would simply record the moment that it got missed, so that later in time we can just look at a note and say, oh, that was missed. We don't have to worry about, well, was it in front of the timeline? Is it past the cursor? Is it all these considerations? So we'll physically mark that on the note itself.
Well, without that, we'd have to basically start off every note as being missed from the outset, and then we're just switching on when they get hit.
But then there's one more case, and let's say you wanted to indicate missed notes by turning them all red as they go by.
Now you need some sort of flag you can throw that will turn those notes red, meaning we now need a missed field.
Exactly. So before they approach, they're not missed yet because they're pending.
Gotcha.
And then once they get missed, then you could have that stored also. So
that's a good name for it, too. Every note would have like essentially 3 states, either hit, missed, or pending.
Right. And so we're leaving that as not hit and not missed means pending.
Gotcha.
So let's drop in the missed field. So we have public bool missed. And as far as data goes, that's it. That's all we need our note to do. It has no functionality. It just needs to keep track of information. Now we will add a public constructor in order to make it easier to create notes in line. So we'll make a public constructor here. So public note. We'll take in some parameters. We'll give ourselves an integer parameter called tick and an integer parameter called track. This way, if we're needing to immediately create and then pass a note along to some other method, we can do so in line instead of a function call. So what we'll do inside of the constructor is make sure we set up our tick field and store the value in our tick parameter, set up our track field, and set that to the track parameter. And while we're in here, we can do this explicitly. We'll set our hit and our miss to false. And again, that's the default value they should get anyway, but we'll do that explicitly here just so that it's obvious what happens when a note gets created. So we can build, make sure everything gets saved out, and really that is it for the note class.
Yeah.
It's just a series of fields and a constructor to make inline code more efficient.
So this was a really short video, but it's a really pivotal class. We wanted to make sure it got some special treatment and wasn't something that we just kind of packed into another video. So that's going to wrap things up for this video. Thanks a lot.